Let us start our discussion on various interoperability protocols. So particularly in this section, we will discuss about the common information model, which is the most common interoperability protocol being utilized in the power system network. Then we will also discuss about multi-speak, which is similar to common information model and being utilized particularly in US geography. And then we will discuss green button, and then we will discuss about the smart energy profile 2.0 and the sun spec. So let's start our discussion on various interoperability protocols. So first, let's start our discussion on the common information model. So the common information model is having three subsections. One is IC 61970, which is mainly for the transmission system. IC 61968 is the common information model for distribution system. And IC 62325, which is related to energy market. Now let us see what is common information model. Common information model is generally represented as a collection of classes. So it is abstract, generalized, platform, and the context independent representation. Abstract in the sense that by default it doesn't have any meaning. You have to develop the corresponding profile to get the meaning out of it. It is a generalized representation of the system where a lot of classes related to all the power system equipments are collected. So in the base, you will have common information model as collection of classes and their relationship. So the SIM will define, SIM means the common information model. So SIM will define the semantics of the message. So it will have to be converted into a profile because in SIM you have close to 1500 classes. So for one particular information exchange, you need not to use all the classes which are there in the SIM. So what you have to do for one particular data exchange, that is the content which you want to share with the application, corresponding to that content, you have to develop the profile using SIM classes. When you develop the profile, it will just give you the structure under which the particular information exchange will happen. So after profile, you need to create the schema, that is the template, which will define how the data will be packed for information sharing. So the schema is the template which will help you to understand how the data will be filled for the information exchange. So SIM used to stabilize the common semantics among stakeholders. So common semantics means the meaning which stakeholders are making out of the information will be same. So every stakeholder who is using the common information model related information exchange, they will be able to understand in the same way it has been created by the person who has initiated the information sharing. So different stakeholders will have the same meaning of the information. That's why it stabilizes the common semantics. It helps in standardization of information exchange because it is based on the standard classes which are part of common information model. So if you want to represent the information, you have to utilize the common classes. So using those common classes, you can represent the information in a particular format. So that's why it will act as a standardization for the information exchange. The domain model of same represents a vocabulary of basic terms. We will see that what are the various attributes we have. So same is represented using unified modeling language, that is called UML. So UML is nothing but the graphical representation of the collection of classes and their relationship. So UML is commonly used software language for the graphical representation of the information, and it helps you to understand how the various classes are associated with each other. One such example we will see to understand how the UML is utilized for the representation of the information. Why we utilize UML? Because it is very easy for human being also to understand how the structure of the information is created. The structure of one such profile, that is state estimation profile, where the state variables are required to be created. Here we will have lot of classes to be utilized for creation of the state variable profile. So in state variable profile we will utilize the tap position, voltage injection, shunt compensator, power flow, voltage, short circuit, or the status of the breaker for topology creation, and various other classes. You can see that to create one profile you need not all the classes which are there in the common information model, but you select few classes which are required to represent the state variable profile. Now here you might have figured out that there are the various attributes which are required to be added in the classes. So these attributes are nothing but the parameters which you want to collect either from the field, or maybe they are calculated or derived using the various algorithms. So for example, in the state variable voltage, we need voltage magnitude as well as angle. So similarly, various classes will be collected and will be associated through various association mechanisms to create this kind of structure. Now you will see there are various symbols being utilized to connect the various classes. So let's try to understand what are the various connections we are utilizing to connect the various classes while creating a particular profile. So in the common information model, we use three basic connections between the classes. One is inheritance. Inheritance means the parent-child relationship between the classes. That means the parent class, that is switch in this case, will provide the basic parameters to the child classes. That means the child classes will inherit the switch properties from its parent switch class. So in addition to the properties given by the parent class, they may have some their own properties also. So that's why we have different classes which are the child classes derived from switch class. So here jumper, fuse, breaker, disconnector, load break switch, all are part of switch, but they have their own specific properties which distinguish them from each other. So inheritance is represented by this triangle symbol. So whenever you have this symbol in the connection between two classes, then you will come to know that this is representing the inheritance. The next is association, where you will have direct connection, and there you will see the numbers written on both sides which shows the cardinality. Cardinality means that the relationship of one to many between two classes. So for example, in this case, conducting equipment that is one conducting equipment can have either zero or many terminals. Similarly, the terminal might have the association with the measurement class, where we can have measurement even if there is no terminal, or we have at least one terminal. So this is 0 to 1 to 0 to n relationship between terminal and measurement. So these are the direct relationship which tells you that it is one to one or one to many relationship. Now aggregation means the part of a particular device. So say for example, transformer winding is part of the power transformer. So the corresponding classes will also be associated through aggregation. Aggregation is represented through diamond. So transformer winding, we might have one or multiple transformer windings in the power transformer, but the transformer winding can be part of only one transformer. Similarly, the tap changer will be associated with one transformer winding, but there might be multiple tap changers connected. So that if power transformer is not available, then transformer winding will also not exist. Based on the previous discussion, you can now see that the various entities are connected in the form of parent-child relationship in this figure. And similarly, we will also see the aggregation and the association connectivities between various classes. So now you can easily understand that these are the three basic connectivities which you will see between various classes. Now, the common information model have the information exchange among computers using XML documents. So when you create profile and then after that you create schema will be nothing but the XML template where you will fill the required data. So the output of the same information exchange is nothing but one XML document. Now the SIM profiles which you just saw in previous slide will specify the subset of SIM classes and attributes for specific business context. That means for one particular data exchange, you need to collect the corresponding classes and create the profile. The implementation technologies such as XML are required to be created in the common information model, which will also help in standardization of the power system model, because the XML output which is used as an implementation technology will help you to create serialized files and messages. Now it will help to standardize the power system model, and it will also help to standardize the information message payload. So because of having the standardized XML document, the applications which are creating SIM document or applications which are consuming SIM document, both will have common sharing of the thoughts, and that means that the information which are being shared will be understood by both of the applications. Now here the SIM UML, that is the figure which we just saw in previous slide, this SIM UML can be extended. So that means that you can extend the class or create a new class. Suppose if you are having another new power system equipment, the class for the corresponding power system equipment doesn't exist in SIM, then you can create that class or extend that class from another class and use it. So there are two possibilities for the extension. That is, one is standard extension, means you create the new class and get it added in the standard SIM model, or you create the private extension which will be the utility specific. Now the data which you want to share among the applications will be encapsulated in SIM XML tags. So if you see this sample SIM file, the various tags which you are seeing are containing the data which is encapsulated between these tags. So the same XML tag will standardize the way the data has to be exchanged among various applications.